Wazuh. We have forked it over into a repository just to make sure that we have control over it. Oh, my headset went out. That's okay. Let's see, microphone's still good. Cool. So then what we want to do is use that repository, come in here. I do believe we had to make, there was a time when we had to make a little change into the code to make sure that the library that it was using was the correct one. Pretty sure that's not the case anymore, so I'm just going to go ahead and say make. Okay, that looks good. Then we have just created the kernel file, and we're going to load it. So, oh, geez, I've forgotten. So lsmod is to read, insmod is to install. Okay, there we go. So let's do this. Perfect. No reply. No reply means good. If I were to go ahead and do it twice, it would give us the error that I believe Thomas was seeing. So that's okay. Then, of course, if we try to look for that, you mentioned live off the bell. I don't think it's necessary anymore. So because of the version that we're using now on these machines. So if it is mentioned in the lab guide, you know, I'll keep it there because it doesn't hurt, but apparently it's not really necessary anymore. So I'm going to go ahead and see, well, what Linux kernel modules do I have installed? I have several of them. If I try to look for anything that says diamorphin, I will be returned blank. However, this kernel is controlled by listening into signal calls provided to anyone. And kill is a good tool for sending out signals. Normally it's used to send out the shutdown signal to anything, but in this case, we're going to be using it for other signals, non-standard signals. So number 31 to any process ID, well, it doesn't have to be that big, but I wanted to make, demonstrate that it is a random ID. Should do something, and I don't think that's the one that I wanted actually. I think that's the one to hide that process. And the one I want is number 34, if my memory serves me right. No. Let's see, let's look at the README. README has that. So 63 to make the module invisible, right? And the other two are 31 and 64, which I'll be using today. So let's go ahead and do kill minus 63, and then the number of the process that's supposed to be random, and then see that we are now seeing our rootkit that's installed in there. We can toggle it again, make it invisible. There we go. And then just to speed things along, we can hide just about any process that we have in our system. I often get a little bit creative here and hide something different than our syslog. But then that always gets me trouble. Sorry. So let's just focus on our syslog. Of course, I don't want to hide the process of ref. I just want to hide that one. So kill minus 31, that is correct now, and hide that process. And if we look again for it, it's no longer there, even though the process is still running. I mean, if we were to look into the activity that is done by our syslog, you would see it there. So you may remember one of the things that the agent is doing is that every X amount of time, let's see how long X is, I believe it's every 5 minutes, is looking for inconsistencies within these two, within the calls of the kernel and of the system. So if we look here into, always have a little bit of time finding here, inventory data commands. Let's see, root check. No, I can export it as a PDF and not a. That's interesting. Well, in any case, a good, easy way to get it to work faster is to restart the agents. Let's go ahead here and look at here is the first one. Root check disabled. No. Yeah, some of the legacy ones have this confusing logic of saying disabled instead of enable. And the frequency is actually every 12 hours. Wow, that's no good. Let's change it to 300, every 5 minutes. And once I push this out, both of my Linux agents will restart themselves. You will look at the different, system calls, ports, all of that information, process IDs, and determine if there's anything that is inconsistent. Okay, so it's now let's go ahead and look if that has happened. We will eventually see the alert. I imagine it might take a 1 minute or two to happen, or not. It might already be there. So you can filter for level 11 rules, or we could look for the word root check, of course, for Linux kernel. Here we go. And we can see on-site kernel. Oh, this is when it was loaded. That's interesting. And then now we have this very second the evidence of the process being hidden and other things. So this process ID was hidden. Let's actually look at the full log, toggle that. And we can see several processes being hidden. In this case, I do believe it's finding rsyslog and related processes to that. So you may see that the process IDs are very much similar to that of the one that I actually hid, right? If we want to turn it back on, we can do so very easily and see that rsyslog reappears. I'm not sure if the other ones will also be there. So actually, we can try that. CPS Fox, and then grep 181.6. Ooh, ref. Not the best typist today. There we go. Only that one. I'm wondering now if the other ones were visible beforehand. Okay, cool things about rootkits. I always like to show these. So if I were to add in a new user, add user add, forget which is the one that asks for a password, I believe it's this one. And let's call him test. No, it was the other one. Anyways, let's change the password for test. No, that's a predictable password. Let's give it our own strong password, better yet. So okay, there we go. So if I were to go ahead and log in as this user from outside, SSH test at Linux agent h0.lab.wazuh.info, provide my password, right? So here I am. Who am I? I'm this user, the user test. I don't have any access, any root access. Actually, it's interesting because apparently my terminal was not also set, but anyway, I have this. However, the rootkit is still installed, and one of the other calls that is not mentioned there on the README is -64. And if I do that, instead of being test, I'm going to be root. Right? So that's the importance of making sure you don't have rootkits there, because then other users, geez, I don't have tab completion. Other users could do things like this, have access to things that they're not supposed to. So it's not only a thing about hiding processes, it's also allowing backdoors. And of course, this is just one example of a user that already has access to the machine. But sometimes people find ways to run commands or send signals via web servers, right? And the web servers run as www-data. So that's, of course, something that we would rather not have on the system. Let's go back into as root. Let's go ahead and send the kill signal to make the module visible. There we go. Let's look at ls mode and grep for diamorphin. And yeah, let's uninstall it, our mod, right? I have more. There we go. And now we no longer have that. If I try to do the kill signals -63, it isn't captured by that system. Okay, great questions. Okay, this is again another feature, something that is there to help you gain visibility. It is not one of the most commonly, things that we see people getting excited over. Give me 1 second. Okay, so great. there aren't any questions, let's move on forward and talk about, well, questions. Talk about the next set of slides. Let's see, presentation deck here. Okay, now we're going to talk about the last part of the rule set that we've been mentioning, CDB lists. And this is going to close off, and it's going to give us, you know, all the full attack of the rule analysis, right? So CDB lists are constant. I thought I fixed that typo. Interesting. Okay, so this is supposed to be CDB, not CBD. I'll have to look into why that typo is still there, but I'll look into it. So yeah, Wazuh CDB lists is a feature that allows Wazuh to look up key values, key end values within a large list and compare them against extracted values observed in events that it is analyzing. Okay, so there are several classical use cases for CDB lists. You have usernames, you have IP addresses, you have domain name, hashes, and many others, right? You have any type of indicator of compromise that can be put in a list. Wazuh can then use to enhance its matching mechanisms, okay? So an example of how to use a CDB list, as I mentioned, it is an enhancement to the rule set. It will be simply a matching criteria. And for example, this rule, this simple rule is a child to another, you know, fake rule. And in this case, it will look for this. If this rule has been matched, it's going to be looking for the field domain, the value that it's decoded in the field domain, to see if it matches any of the ones that are mentioned here in list bat domains. Okay, and then allow us to do to provide that additional context. For this can be used for, you know, different things. You can have a list of things that you want to allow or to block, or simply to provide additional context into what a key means normally within an event. Okay, it is important to note that the lists are configured in the rules, but you also need to tell the rule set to include that list as part of its matching mechanism. And finally, of course, you do need to create the list. So working with CDB lists will be a three-step process, right? Create the list, add it to the rules, and then add that list to the manager's configuration on lists, right? You don't specify the whole folder, you do specify individual files. Great, so let's go ahead and do exercise 5A. 5B is also going to be on CDB lists, but I want to do 5A first. Let me know if you have any questions.